So, welcome everybody to this week's exercise session, which will actually not deal with a problem set, but where we will talk about two papers within the topic of optimal income taxation. Yeah, so I already uploaded the papers on Moodle, and I will also upload the slides that you can see here, including some of the notes that I will make. Because yeah, I might add some information to what I've prepared here on the slides. So I will upload two videos on the YouTube channel. So the first one is about one paper, and the second one is about another paper. And yeah, so you can better distinguish the two papers when you want to inform yourself about them. Okay, so yeah, today it will be about optimal income taxation, and we will talk about two papers. The first one is basically the seminal paper in optimal income taxation. So I guess everybody who somehow has to do something with taxation knows this paper. So it's the 1971 Mirlees paper, an exploration in the theory of optimal income taxation. So it was published in Restat and had a great impact on a lot of other papers which were building upon this. And I call this the, so with respect to the topic today, I call this the butcher paper because the analysis is quite demanding and quite messy. So it reminds me of a butcher who somehow butchers his way to his results. And the second paper that we will talk about is from Science in 2001, which is related to the paper, and the name is Using Elasticities to Derive Optimal Income Tax Rates. And I call this the surgeon paper because it takes kind of a finer approach and it's not as messy as the Mirlees paper, even though I'm not judging here and saying that the Mirlees paper is a bad paper. I'm just saying that it's very, very complicated and demanding. Okay, so we'll start with the Mirlees paper. So the Mirlees paper is basically one of the first papers which yeah, kind of uses economic theory to derive features of an optimal income tax schedule. Yeah, so there were papers dealing with this topic before, but I guess like there was no paper which did some rigorous analysis using math and trying to yeah, use economic theory to kind of pin down or sheet lights on questions or things which were happening by that time. Yeah, keep in mind that this paper was written in 1971. Yeah, so this is this is a different time than today. Yeah, so many things which you might read in the paper might somehow not apply to nowadays, but yeah, just keep this in mind. Okay, so the setup in the paper is actually quite general. Um, and as a consequence, the analysis is very demanding. But the issue is here that the author is only able to derive a few general properties of optimal tax schedules in the paper. And you will see why it is the case if you read the paper. Yeah, so in my presentation, I will not go into the details of the derivations, but if you take a close look to the paper, you will see that it's very complicated to make any statements at all. So the author is only able to derive few general properties. A key assumption here is that the government cannot observe income generating abilities. So the government cannot observe what actually the talent of people or the skill of people, which makes people actually earn higher incomes because it should be correlated. But um, yeah, it can observe income, and as I just said, income should be positively correlated with abilities. Yeah, because people who have higher ability should, on average, of course, have higher income than people with lower ability. Yeah, if you can pin it down to a one-dimensional ability parameter, but I guess it's a good approximation. What the government then can do is it cannot impose a tax schedule based on abilities, but it can impose a tax schedule based on observable income. Yeah, so this is possible for the government because it can observe the income. The main finding of the paper, so if you want to summarize everything, so I mean, there are other findings, but like the main key takeaway from the paper is that marginal tax, that's a surprising thing, that the marginal tax rates should be zero at top income levels. So for people with the kind of who are at the upper boundary of the income distribution, the paper is saying that the marginal tax rate here should be 0. And actually, it's not, so at least to the best of my knowledge, it's not shown in this paper itself, but other papers which are referring to this paper are using the first order conditions of the optimization problem here and show that it's actually indeed the case. Yeah, so I think the result here is not found in the paper, but nevertheless, it's kind of the main takeaway of the model in this paper. Yeah, so just a quick kind of jump to the SARS paper. So SARS is basically deriving features of an optimal tax schedule by using elasticity, so income elasticities with respect to tax rates. Yeah, so he's linking kind of an optimal tax schedule to elasticities of labor supply when the marginal tax rate is changing. And what he basically finds is that the optimal tax rate, so the optimal income tax for high incomes, actually depends on some elasticities, which have a nice economic meaning, and the thickness of the top tail of the income distribution. Yeah. So how much probability mass do we have on the tail, on the right end tail of the income distribution? And he derives a quite simple relationship there. In addition, he's able to give an economic intuition for many different effects, which kind of come to play when a government is changing the marginal tax rate. Yeah, so you can think of many behavioral responses to a change in marginal tax rate, and he is able to give like an economic intuition. And what he basically does is that he takes the first order conditions in Mirlees that we will that you can see in the paper, and he identifies the key parameters in those first order conditions which determine the optimal tax schedule. Yeah, so this is why I called him the surgeon before in the beginning, because he's pinning down what actually matters and is able to identify this. Yeah. So, but as I said, we will start with Mirlees. So, yeah, let us come to the Mirlees paper. So, what's the starting point of the paper? That's always important if you talk about a paper. So, what's the issue? So the issue of the paper is that many countries use progressive tax systems to promote equality. So by that time, he in the paper he was also referring to Germany and US and UK. So those countries they were using progressive tax systems in order to promote equality. So equality basically in terms of there should be kind of a convergence of low income people and rich income people. So, by the time there was a wide discussion about tax rates on low and high incomes when it's about equality. Um, so intuitively, one would say if you want to have equality, you should have higher tax rates or higher marginal tax rates on higher incomes. But the issue for the time was that there was no relevant economic theory which people could refer on or refer to in order to answer some of the questions, yeah, that you would ask yourself when it's about incorporating optimal tax schedule. So, for instance, one would be, um, can we somehow use economic theory to quantify the efficiency versus equality trade-off? Yeah, so obviously, if you increase marginal tax rates for high income people, yes, you probably will raise tax revenue due to higher marginal tax rate, but at the same time there might be a behavioral response of the high income people which might decrease efficiency. Yeah, so in general you would think of a trade-off between efficiency and equality, and he basically asked the question, so can we quantify this? Can we somehow use economic theory to derive an equation which somehow can be estimated with real data? And the next thing that you could do is you can think of normative aspects of an optimal tax schedule. Yes, so what should an optimal tax schedule somehow fulfill? Those are questions that you can kind of sheet light on when you use economic theory. But the main question of the paper is actually, are there general features of an optimal tax schedule that one can derive using economic theory? Yeah, so this is the basic or the main question in this paper. So what this paper does is that it's yeah, providing the first rigorous economic analysis of optimal tax schedules. So there were papers before, but they were like probably they were more verbal or looking more into data, but not really yeah, using math or economic theory to kind of deal with optimal tax schedules. Um, so this paper is kind of achieving results which are very weak. So they kind of like Mirlees is able to derive results, but the features of an optimal tax schedule that he derives, they're not kind of, how do you say, they're not specific. They're very general. So they have a limited use for application. Yeah. So when a policymaker is looking at the results, there is not much that he can derive from this actually. Yeah. So that there is limited issue for limited use for application. But nevertheless, the paper itself is very important because it basically started this economic literature, economic theory literature on the theory of optimal income taxation. So before we introduce the model, I will also stick a little bit to the structure of the paper itself, in that I will also talk about the assumptions that the author is mentioning before he even talks about the model itself, just to kind of show you um, like this paradox that even though he is making a lot of simplifying assumptions in the paper, the analysis is still very demanding, and the results are still kind of very weak. Yeah, so even though he's making a lot of assumptions, the analysis is demanding and the results are weak. So this should show you that the topic itself is quite demanding. At least for that time, it was quite demanding. Of course, nowadays you have different techniques, like from economic theory. You have more data. There is much more that you can do nowadays compared to 1971. But still, this should show you somehow that yeah, the topic itself is quite complicated. So the first assumption that he's mentioning is that in the model that he's considering, there is no time dimension, which means that the consumers or the individuals in the model and the government, they're short-term thinkers. So it's a static model. So they live for one period and that's it basically. So they optimize whatever their or they maximize whatever their objective function is given their constraints just for one time period and they do not look forward. So you could think of an issue with this because in reality, people kind of live for more than one period, and tax schedules are actually changing over time, and people form expectations. So it's nothing which is really static, and beliefs play a big role here. So expectations on the future. So, I mean, if you're familiar with kind of macroeconomics or trade, you know, the Ricardian equivalence theorems, which basically are somehow, yeah, also dealing with the topic of taxation, but from a dynamic perspective and showing that some things which might be working out in a static case do not work out if you have dynamics. So yeah, the paper has no time dimension here. Then there is homogeneity in preferences. That is to say that all the agents in this model have the same preferences. Okay, so there might be so in the paper itself there is kind of heterogeneity with respect to skill, but with respect to preferences there is no heterogeneity there. The third assumption is that individuals are rational. Okay, so they have preferences which fulfill the axioms of choice. They do not make any mistakes, so there is no bounded rationality here. So individuals have well-defined preferences and are able to maximize their utility. So they make choices according to a utility function. The fourth assumption might be a little bit problematic because if you think about the issue of taxing high income people, you could imagine that if you do not allow, so the assumption here is that migration is not possible, which is basically saying that people cannot leave the country where the tax schedule is applied independent of what tax schedule is actually applied. So even if the government would go to them and steal them 100% of their income, they're not able to leave kind of the country, but they're forced to stay there. So if you would allow for migration, it might somehow, yeah, it has an impact on the elasticity of high income people, not only high income people, but also other peoples in the income distribution. So if you do not allow for migration, the elasticity, so the response to tax schedules might be different compared to a situation where migration is possible. Yeah, so this is a quite yeah, strong assumption that he's making here, but yeah, that's the way to go. If you would allow for migration, you would have like a two-country model, and then the countries somehow are competing with each other, and this really complicates the model, I guess. The first assumption here is that the government has perfect information about individuals. This is wrong in the way that I've been writing it here. So the government has almost perfect information. The only thing which it doesn't know is the skill of an individual. Yeah, so it has no information about the skill of the individuals. So let me just write this down. So no information about skill. But apart from the skill, it knows the utility, so the preferences, the form of a utility function, it knows the income, but the only thing that it doesn't know is yeah, it doesn't know the skills of individual, but it knows the distribution of skill in the population. The next assumption, assumption 6, is that there is one type of labor and one type of consumer good. Yeah, so yeah, basically it's kind of you either consume one good or you consume leisure, basically, by not supplying labor. Those are the only two goods that we have in this economy. This shouldn't be too restrictive, actually. So you can think of representative labor and representative goods, but I don't think this is a big issue here. The last point here is that implementation costs of the optimal tax schedule are negligible. So this might be an issue in that if the optimal tax schedule is very complicated, nevertheless it's optimal, but it's very complicated, the costs of implementing it might eat up the benefit that you have from an optimal tax schedule. Yep. So if you would introduce the costs of a tax schedule and the costs somehow are increasing in the complexity of the tax schedule, then what might happen is that the optimal tax schedule without costs is not the same as the optimal tax schedule what you would consider the cost. Yeah, so it might be the case that a very simple tax schedule, which might not be optimal in the first best sense, might still be optimal if you because you have low or almost no implementation costs for this. Yeah, so you could think of a very simple thing. So if you have a linear tax schedule, this is a very simple this is a more simple tax schedule than when you have a highly nonlinear tax schedule with different marginal tax rates. And in addition, if you have kind of a tax schedule where everybody is paying the same tax rate, this is the most simplest thing that you can think of because you do not have to monitor or condition the tax payment or the marginal tax rate on the income that somebody is getting because everybody is paying kind of the same rate from his income. So yeah, those are the 7 points, which are yeah the seven assumptions which are made in the paper. Some might be more restrictive than others, but yeah, as you will see, or as you can see in the paper, the analysis is still, even though he's making those assumptions, it's still very complicated. In addition, the results which are derived are quite weak, so at least from an application possibility. And basically what this paper pointed out, at least for that time, is that the study of optimal income taxation can be very complicated, yeah, at least for that time. Good, so let us jump into the model. So we have individuals in an economy, and they have preferences, and the preferences are homogeneous, and they are represented by a utility function which depends on two variables. So the first one, x, which is weakly positive, denotes consumption of some consumption good, and y denotes the working time. And in the paper, y is normalized to be weakly positive and strictly larger than one, strictly smaller than one. This is done without loss of generality. Yeah, so you can have higher amounts here as the upper boundary, so this doesn't really affect the results in the paper. So the utility function is well behaved, so it's strictly concave, it's continuously differentiable, it's strictly increasing in consumption, so the good is actually a good and not a bad, so the more you consume from it, the better it is. And it's strictly decreasing in working time, yeah, so because you have costs of labor or effort costs, the more you work, the less kind of leisure you have or free time you have. So you can think of not only y here, but you can think of 1 minus y defining leisure. So this somehow affecting your utility function in a positive way. And then if you increase y, then you decrease basically leisure, and this is decreasing your utility. Yeah, so you can think of it in this way. So individuals are heterogeneous with respect to the productivity. This is what I mentioned before. So this is the only source of heterogeneity that we have. So is he modeling this? So he considers that an individual with parameter n provides quantity of labor y times n when he's working y. Yeah. So a consequence of this is that the higher n is, the more labor can be supplied by an individual with fixing y. Yeah, so think of n as kind of a productivity parameter, and the higher n, the more this person can supply with respect to labor when fixing his working time. And as I said before, the government knows that this ability parameter or the skill parameter is distributed in the population according to some CDF on the interval which is given here. So then for further notation, the consumption and labor supply choice of an N agent. So when I'm referring to an N agent, I'm referring to an agent which has ability N. So given his ability, we will denote his consumption and labor supply choice in equilibrium. So an optimum as this tuple here. So I will put the n into the subscript, and then his total labor supplied is then simply, so in equilibrium, is then simply his ability times the working time in equilibrium. So now given those optimal values, what we can then derive is the aggregate correspondences of this. So the total labor available in the economy, so capital Z, is then simply the individual labor supplies, and we sum this up over, or we integrate over the support of skill in the economy, and then we basically get the total labor which is available in the economy. So this is what the government and the consumers can use for consumption. Then at the same time, we have capital X here, which is denoting the aggregate demand for the consumption good. And this is simply the integral over scales for the individual demands for the good depending on ability. So what are the individuals doing? So the individuals are choosing this bundle xn, yn, so they're choosing their amount of labor which they supply or their working time, and they choose their consumption given their budget constraint. So the thing here is that by an income tax that the government is imposing, it basically affects the budget constraint. Yes, so if you kind of if your income is endogenously determined by your working time, and there is a tax rate which you need to pay depending on how much income you generate, then basically the government is directly affecting your net income by an income tax. And it is modeled here by a government which chooses a function C. So C is a function such that an individual who basically supplies Z units of labor can consume a maximum of C of Z. Yeah, so if you, for instance, just a very simple example, if C is the function which takes everything minus 2, and you supply, not minus 2, that's too much. So let's say which subtracts from everything 0.5, then if you supply, if your labor supply is equal to, to 1, then basically you can consume a maximum of 0.5 after taxes. Yeah, so this is the C function in a very simple way, but it can also be more complicated. So this bundle xn is maximizing utility subject to the constraint that the individual can only consume a maximum of what is left for him after the tax is applied to his labor supply. And by UN, we denote the indirect utility of the N agent. Yeah. So if we solve the optimization problem and we plugged the optimal solutions back into the utility function, we get the indirect utility function, and this only depends on the parameters of the model, on the exogenous parameters. So there is a preliminary result in the paper, which is referring to the working time depending on the skill that an individual has. And proposition one is basically saying that there exists some kind of a threshold skill level such that this skill level is so this threshold is weakly larger than 0, such that all individuals who have ability less or equal to this threshold will choose a labor supply or will choose a working time of 0, and all individuals with higher ability will choose a strictly positive working time. Yes, so the intuition here is that low ability individuals do not choose strictly positive labor supply in optimum. Yeah, so there will always exist kind of individuals who will choose to not work or not choose any strictly positive working time. Yeah, simply because their ability is so low that the productivity, so the skill is so low that the productivity is very low, and basically it's just not worth for them to work. So the costs are too high, if you want to state it like this. This should be proposition 2 here, and not proposition 1. Sorry. Proposition 2. Any function of n, x and yn that is a solution to the optimization problem of the n agent for some upper semi-continuous function c also solves the optimization problem for some non-decreasing right continuous function c prime. And it's a little bit difficult to uh, give an intuition for this, but the idea here is that the marginal tax rate that the government does not if you think about the big set of tax schedules that a government can impose, then here the proposition is saying that the marginal tax rate does not need to be larger than 100%. Basically, it's saying that the marginal tax rate needs to be between 0 and 100%, which is basically kind of restricting the set of tax schedules that the government needs to consider. So this is something which you might be familiar with if you had a course on mechanism design. Because in mechanism design, what you typically try to do is you try to simplify the optimization problems that you have there by restricting the set of functions that the mechanism designer needs to consider. And here it's basically, of course, not in the language of mechanism design, but basically it's the same thing here. So we do not need to consider the potentially very large kind of set of tax functions, but we can restrict ourselves to tax schedules where the marginal tax rate is between 0 and 100%. Yeah, so this is the intuition of proposition 2. So, what is the objective of the government? So, now that we have an indirect utility function of the individuals, so we act as if the government has already chosen C. For a fixed C, the kind of all individuals or N agents have their indirect utility functions. And now we go one step back, basically, in that we now consider a situation where the government is basically choosing C, so the tax schedule, to maximize a welfare function, which is given by this expression here. So what is this welfare function looking like? So basically, it's the summing up all the individual um, indirect utility functions for the N agents, and then it's applying some function g on them, and this g function can somehow be interpreted as the social utility that the government derives from an N agent. Yes, so it gives the government kind of the tools to think about either think about efficiency or think about equality and all these kinds of things. Yeah, so G basically um, yeah is determining can determine the goal that a government has with respect to equality. So for instance, if this G function is strongly concave, so strictly concave, but it's a very strict concave function, this means that the marginal social utility is much higher for low values of UN compared to high values, yeah, because it's a strictly concave function. So if then a government is choosing C to increase, so to maximize this W function here, so the welfare, then it cares more about increases in utility for people with low N, so with low income, rather than people with high N. And therefore, this is a situation where you could think of a government having the goal of equality more than a situation where, for instance, this G function would simply be linear and the government would simply add all the functions, all the indirect functions with the same weight. Yeah? So think of G basically putting, depending on the shape, of course, putting more weight on a particular group of individuals in the society. So this is the objective function. So the welfare function is the objective function. The government also faces kind of an aggregate production constraint, which is given here. So total consumption in the economy, so total consumption or total demand with respect or from the consumers needs to be smaller than the production, so total production, and then we apply a H function on this, and you can think of H representative kind of technology, can represent a technology, so which somehow yeah maps from the labor supply into kind of the measure in which the consumption goods are embedded. So this is just like to be as general as possible. So you can also think of this H function as kind of a, so not only as a production function, but you can think of H also kind of taking some parts of the production away because the government needs to raise revenues for a product. Yeah, so H could simply be a function which subtracts something from capital Z. So the government needs to build a street and then it's taking some fraction away from capital Z. And this is then not available for the consumers, yeah, in order to consume the consumption good. Okay, there are two additional assumptions in the paper. So one is so it's I think they're called A and B in the paper. So A is kind of making sure that the solution of the individuals when they're maximizing the utility function with respect to consumption and labor supply or working time. So it's making sure that the solution is unique. So um, assumption A is basically saying that Yn is uniquely defined for all n except for a set of measure 0. Yeah, do not worry so much about this. This is just a technical thing here. Um, and basically what it does is that, yeah, this further restricts the class of functions from which the government chooses a tax schedule C from. And actually, it's quite easy to show what the issue here is. So why it's important that the solution is uniquely defined. It's simply because when you want to do welfare analysis and you have individuals who have different indirect utility functions, then the question is which one do you consider for welfare? Like, how can you say that the if you do not have a unique solution, but you have many solutions, how can you guarantee that one of the solutions is picked? Yeah, so you have an issue there when it comes to welfare, and the issue. So why kind of we have a problem when the tax schedule is kind of complicated is the following. So just consider the following situation. So in this economy, what we have is we have two goods, if you think about it. We have good one, which is the consumption good, and then you can think of the second good as being leisure. Yeah, so one minus y, one minus the working time. And so then, depending on your utility function, what you will have is you will have an indifference curve. Yes, so you will have an indifference curve. And given the assumptions which were made with respect to the utility functions, the difference curves in this model, they're nice behaved. So they're like as typical indifference curve that you know. So they're strictly decreasing, they're strictly convex. And then typically what you have in like an introductory microeconomic course is that as long as the indifference curves are looking like this and you have a budget constraint which is linear, so what you will have is that you will have a unique solution, and this will be given by the bundle where the indifference curve is tangential to the budget constraint. Okay, so this is the classical situation that you would have in a normal microeconomic course. But now the issue comes, like there is one issue related to the tax schedule. So because the tax schedule, depending on how it's looking like, can be nonlinear. So depending on how much working time you're supplying, the price of leisure changes. So this means that the budget constraint could have a kink here. So I'm just drawing one very simple example. So it could be the case that you, until some point of leisure, you have kind of a budget constraint which has this slope, and then suddenly it's like this. So it has a different slope because you have a nonlinear tax schedule. And then depending on how your preferences are looking like, you can have an indifference curve which is then tangential here, and at the same time it's tangential here. So you have 2 points where the indifference curve is tangential to the budget constraint because the budget constraint is not linear anymore. And then the question is, which one of those 2 points do you consider when you want to maximize welfare? Yeah. And in order to avoid those issues, uh, the um, the author is simply making the assumption that yes, yn is uniquely defined. Yeah, so this kind of does not allow for any tax schedule which kind of creates a budget constraint such that the solution is not unique anymore. But of course, this also crucially depends on the preferences. Yeah, when you have a non-unique solution. So yeah, it restricts the set of yeah tax schedules that the government chooses. The second assumption here is assumption with respect to the preferences of the agent. So it's a little bit would take a lot of time to pin down kind of what this condition is exactly saying. So at least to the best of my knowledge, it's basically saying that um, um, this assumption is diminishing the magnitude of an income effect on consumers' demand for the good. So basically, it's making leisure also a normal good. So a good which such that the demand for this good is actually decreasing if the price for it is increasing. Yeah, so it's kind of making sure that when later the author is doing all those first order conditions and then yeah thinking about comparative statistics, it's making sure that you get clear signs for the expressions that you're considering. Yeah, so it's not very important, small technical thing. It might not be always fulfilled, of course, depending on what preferences you have, but this is kind of a more technical assumption here. Okay, so Then the thing with this paper is that it does not make any sense to go into the details of the derivations because they are yeah, very complicated actually, and they go far beyond the scope of this course when it's about I think in the lecture you have a simple derivation there of the text schedule, but the Mirlees paper itself, the derivations in this paper itself, they're very complicated, and I don't think it gives you, yeah, it doesn't have any benefit for you to see the derivations. If you're interested, please have a look into the paper, but for the paper presentation itself and for the results, it doesn't actually matter so much. But you might learn something if you take a look into the paper. So then, given that we have those two assumptions here, the author then proceeds to the optimization problem of the government to solve it. And so what is the optimization problem? It's basically the government choosing a tax schedule, which in turn then determines what the agents in the model are consuming and how much labor they're supplying. And the government is choosing this tax schedule to maximize welfare, conditional on the production constraint, so that the total demand of the consumption good must be weakly larger than h, so the function h applied on the total production in the economy. This is one constraint, and the second constraint is kind of the first order condition of the individuals, yeah, so that all the individuals are maximizing their utility. Yeah, so this is kind of the explicit, so it's an explicit kind of incorporation of the assumption of rationality in the model. What I will do now is I will simply yeah, summarize the main results depending on the assumptions which are made in the paper with respect to the utility functions of individuals. So basically, there are two kind of main assumptions there. So first, it's kind of the general utility function assumption, which is basically what I introduced in the model description. So there he's not making any further assumptions with respect to the preferences. And what results does he have here? So the first one is like what I showed you before. The marginal tax rate lies between 0 and 1. Okay, so this is what we had before. So you do not need to have overcomplicated text schedules, but it's sufficient to consider text schedules where the marginal tax rate is between 0 and 1. Then another feature is that, yeah, consumption and labor supply, so the solutions of the individuals optimization problem, they are varying and continuous with respect to ability n. This is another feature. Then some individuals will choose not to supply strictly positive labor. This was proposition one. Then, I mean, this is obvious, but nevertheless, the optimal tax schedule like strongly depends on the distribution of skill in the population. So what you will basically have is you will have a very complicated set of first order conditions. So basically, they are integral conditions or differential equations. And what you can see is that, okay, somehow the optimal tax schedule depends on the distribution of skill in the population, but it is not clear at all how it depends on it. Okay, so what you cannot do is you cannot make statements as the marginal tax rate should be higher for high income groups, or you should have a flat income tax, or something like things like this. You're not able to give a clear answer to those questions in the situation where you have a general utility function, which I introduced before. Yeah, so the kind of results here are fairly weak. Yeah, so if you think about a person like a politician who wants to, yeah, think about what tax schedule to impose in order to promote more equality, those results do not really help them. Yeah, so that's an issue. So what he then does is he makes an assumption with respect to the utility function in that he's considering an additively separable utility function in labor and labor supply and consumption. So the technical kind of incorporation is that you simply assume that the cross derivatives are zero, So basically, it means that in a very simple way, so the most simple way that you can think of is that u is simply x minus y. Okay, so this is an additively separable function. So in a general way, it basically means that you can rewrite the utility function in f of x minus g of y. Okay, and then f and g can be as complicated as you want, but the most important part is that you can additively separate those two components of the utility functions from each other. And yes, that's what basically the what he's assuming now in this. I think that's the last section of the paper, and then he's yeah, using simulation. So he's simulating um, kind of the formulas that he's getting from this more simple model, and he's using different income distributions for this. And what he finds is that, yeah, the optimal tax schedule is very sensitive to income distributions. So, depending on what parameters he's choosing for the income distribution, he suddenly have a progressive tax schedule. Sometimes he has a degressive tax schedule. And what he finds most of the times, actually, for his assumptions, is that the tax schedule seems to be fairly linear, and it's and tax rates in general are very low uh, whenever the variance of income is sufficiently low. Yeah, so kind of if you think about application, so since you cannot observe ability, the only thing that you can rely on is income. And then now he's saying that, okay, if the variance of income is low, then the optimal tax schedule is linear and the tax rates in general are very low. And under this assumption, basically what he's concluding is that income tax somehow, at least for those assumptions, does not seem to be an effective tool to solve equality concerns because, yeah, as a result, it's giving you kind of a linear tax rate and a low tax rates in general. But then the opposite holds if you consider a distribution where you have high dispersion of skill. So you have a high variance of skill or kind of income in the population. And in addition, one other thing which is important is that, yeah, um, other aspects, as for instance, the preferences, so the shape of a utility function, and also the production function, they also have a very strong impact on the results. Yeah, so depending on them, the tax schedule is changing, the optimal one, and also yeah, the welfare function is changing. So a lot is changing when the primitives are changed here, and it's very unclear what is actually kind of driving the results. So it's more kind of showing that, okay, everything is possible in this model. So we can have situations where we have a progressive tax schedule. We can have a situation where we have a degressive tax schedule or a linear one, but it's not very clear. So here is talking about variance, but then if you think about preferences and production functions, it's not very clear what's driving the results. So it's kind of a model where everything is possible, but this has limited use for application because you do not know what exactly is driving the results. So this brings me to the conclusion of the Mirlees paper. So this paper derived some general properties that an optimal income tax schedule should fulfill. Yes, so from a normative perspective, he's deriving some general properties. He showed that, yeah, even when you have those restrictive assumptions in the paper that he's considering, yeah, the optimal tax schedule is still very sensitive to the primitives of the model. Yeah, so even though he already has a lot of assumptions, changes in the primitives, so changes in the preferences or changes in the distribution of income or skill, yeah, it has a huge impact on the policy implications depending on what your goal is. But nevertheless, even though kind of the scope, the scope of this paper being the scope of application of this paper being limited, the paper itself actually had and still has huge impact on the literature on optimal income taxation. Yeah, so It's a seminal paper. It's a very nice paper. It's a complicated paper, demanding, but nevertheless, yeah, it was a very important paper for the literature. And in the next video, I will continue on the paper of SAS.